Hi there. In this video we're going to look at the volume of cones. Now in our last video we saw that the volume of a pyramid was a third times by the area of the base times by the height, and it's exactly the same for a cone, except we can write this maybe slightly more concisely using the formula for the area of a circle. So let's just draw ourselves a cone. It doesn't have to be an isosceles cone, it can be any sort of cone. So if it's got a radius r and it's got a height h, I'll draw that in red, then I know that the volume is a third times by the area of the base times by the height. And now because we've got a circle, if you've got a full cone, a full circular cone, and then the area of the base is just pi times by the radius squared. So if I've got a circular based cone, and we'll have a look at semicircles as well, but for this one our volume is then just 1/3 times by the area turns into pi r squared times by h. Okay, so on to our first example. Now if you do think at any point you can have a go at the question before I do, feel free to just pause the video and have a go, and then you can check your work against what I've done as I go through. So we have a cone, height of 12, radius of 4, full circle on the base. So we can either use the full formula that we worked out just a few moments ago, or we can do it the same as the pyramid, work out the area of the base and then substitute into the formula. Just for consistency I'll do the second one. So let's work out the area first. Well, the area is pi times by the radius squared, and the radius in this case is 4, so that's just pi times by 4 squared. 4 squared is 4 times 4, which is 16, so you get 16 pi. Or if we wanted to approximate that, it would be 16 times 3.14, 50.24. Again, this is your exact answer and this is your approximate answer. So if the question asks you to leave it in terms of pi, this is the answer you want to give, or this is what you want to work with. That's in terms of pi, and this is to 2 decimal places. Okay, so we've worked out the area of the base. Let's carry on and work out the final volume. So I know that my volume is equal to 1/3 times by the area of the base times by the height of the cone. And we've got 1/3. The area we've worked out is 16 pi. Now just so we're a bit more accurate, I'm going to use 16 pi in our calculations here. If you're on a calculator paper, you could use 50.24, but it's better to keep it in exact form until the very end if you can, because you'll get slightly less rounding errors at the end. But again, in an exam setting, using this will be absolutely fine. And then times by the height, which is 12. Now let's work that out. So 1/3 of 16 you can't do nicely. You can do 1/3 of 12 nicely though. So we'll start with that. 1/3 of 12 is 4, and then 4 times by 16 is 64 pi. So that's our answer in exact form in terms of pi. If we wanted to work it out, an estimate, an approximation, 200.96 centimetres cubed. So again, either of these answers are fine. This one is your exact answer, and this one is your approximate answer. If you did do this at home and you managed to get one of these answers, well done, that's really good. Okay, so on to our next example now. So in this example, we've got a semicircular cone. So it's half a cone, and we're told that the height is 18, and we're told that this length here is 10. So exactly the same method as before. We'll find the area of the base first, and then substitute it into our formula over here. So remember the area. Now, we've got a semicircle. So what we'll do is the first thing let's draw this out actually. So we've got a semicircle, which is 10 across. So what we'll do is, we'll work out the area of the full circle. So we'll pretend we've got the full circle and we'll work out what the area of that is. And then we'll use that to work out the area of our semicircle because we've only got half of our circle. So the area of full circle is pi times by the radius squared. Now, I've tried to trick you out here, I've tried to catch you out because we're not given the radius, we're given the diameter all the way across. So actually, we need to just remind ourselves that the radius is equal to 5. Again, that is a really, really common mistake, and it's something that examiners love to do. They'll give you the diameter, but you need to work out the radius. And again, if you're doing this in anything like engineering and you're measuring the diameter of a circle, which is much more easy to measure than the diameter or the radius of a circle, if you've got something in front of you, you need to remember to half it to get your radius. Anyway, so the radius is 5, so then the area is pi times by 5 squared. 5 squared is 25, so we get 25 pi. So that's the area if we had the full circle. We don't have the full circle, we only have half a circle. So the area of our semicircle is just a half of this, which is 12.5 pi. Now again, for this one, I'm going to leave it in exact form until the end of the question, and then I'll do my rounding then. Okay, so let's now substitute it into this formula. So we've got the volume is equal to 1/3 times by the area times by our height. We've just worked out that our area is 12.5 pi. And our height, we're told, is 18. So again, we can use a similar trick to before, work out 1/3 of 18 first, which is 6, and then do 6 times by 12.5. Or 2 times by 12.5 is 25, and times that by 3 to make it up to 6, gives me an answer of 75 pi. And again, if you're asked to do this to decimal places, we'd then do 75 times by either the pi button on your calculator, or just 3.14, and that gives you approximately 235.5. There we go. So again, we've got an answer in terms of pi, and we've got an answer to 1 decimal place, an approximate answer. Either is fine. This one is more exact. This one is easier to intuit and see what it actually represents. Okay, so on to our third example. So in this case, we're told what the volume is, and we're asked to find what the radius of the cone is. And so as with all these working back problems, we need to think, how did the author of the question get to this answer? And what must the radius have been for that to have worked out? So again, if you want to have a go at this at home, pause the video and then you can check your answer once we're done. And actually I'd encourage you to do that at this point, because I think it's good to get that practice in before I just explain it all. Okay, so to get this answer of 314, what the person writing this question did was they did 1/3 times by my area times by my height, and that got me an answer of 314. Okay, now I know the height is 6, so they will have had no problems with that. 1/3 times by a times by 6 is equal to 314. So now we just need to work out what area must they have worked out for this to be true. So at some point they'll have worked out the area using the pi r squared, and we need to know what the area was, and then we can work out radius. So let's tidy this up. 1/3 of 6 is 2, so I know 2 times by area is 314. Well, if 2 lots of the area are 314, then 1 lot of the area is just half of that, which is 157. So I know that the area that they worked out was 157. So now we need to think, okay, what did they do to work out that the area was 157? And again, we know that they will have used pi r squared. So they've done pi times by the radius squared is equal to 157. So now we just need to solve this equation to work out what r is. So we want to get r on its own, which means we need to get rid of the pi and we need to get rid of the squared. Now again, with a really common mistake that I see some students do is they square root first and then forget to square root the pi. So some advice that I always give is that try and work from the furthest thing away from the r and get rid of those first, working in towards it, because then you're less likely to make little mistakes like that. So the furthest thing away from this r is this times by pi. So if we want to get rid of that times by pi, we need to divide both sides of the equation by pi. So we get r squared is equal to 157 over pi. There we go. Now, this doesn't look like it's a very nice number. So at this point, I might be tempted to type that into my calculator and get an answer, but we've not got many more steps to go. I've only got this one more step, so actually I think in this case we'll leave it exact until the very last step, and then we'll type the numbers into a calculator to get an answer. So now the next thing we've got to do is get rid of this squared. Now the opposite of squared is square root, so I'm going to square root both sides, and that gives me that r is equal to this lovely looking thing, the square root of 157 over pi. Now again, because lengths are generally positive, we don't need to worry about the negative square root. But we do need to deal with this a little bit, because that, even though it's exact, isn't all that easy to read. I certainly wouldn't be able to tell you what that's about without some pretty decent thought going into it. So in this case, we'll get our calculators, and the Casio calculators are really nice because you can type it in exactly how it is. So 157 over pi, and that gives me an answer of 7.069, or approximately equal to 7.069 centimetres. Now in an exam, they'd specify an accuracy, they'd say to 2 decimal places or to 1 decimal places, but I'm going to leave it like that. So if you did manage to have a go at this at home and you got something like this, then well done, that's really good. Good job.